We shall commence this module by discussing regulation on environmental issues. Regulation to address environmental issues can take various forms like command and control regulation, market-based instruments, and in some cases voluntary initiatives. The choice of instruments addressing environmental problems depends largely upon constraints and limitations of each approach with respect to specific problems. These constraints could be political, informational, market distortions, etc. While evaluating different environmental policies, we must take into consideration two economic goals, namely economic efficiency and cost effectiveness. Economic efficiency is generally expressed in terms of Pareto optimality, which is referred to as situation where any reallocation of goods or rearrangement of production cannot make someone better off without making the other person worse off. Markets can guarantee efficiency in the absence of market failures, externalities, and government intervention. However, government intervention may be required when market fails or externalities are generated during production process. The effect of the externality can both be positive and negative. Some of the examples of positive externalities are benefit from education and telephone connection. The negative external effects include costs of environmental pollution, etc. The government is always interested in achieving the socially optimal level of externality, say pollution. The socially optimal level can be achieved by reducing emissions until the point where the marginal abatement benefit is equal to the marginal abatement cost. Marginal benefit refers to benefit obtained by reducing emissions by 1 unit. Marginal abatement cost is equal to the cost of abating 1 additional unit of emission. When all the firms operates until a point where the marginal cost of reducing pollution by 1 unit is equal to marginal benefit of reducing pollution by 1 unit, then efficiency is achieved because marginal abatement cost is equalized across all polluters. Now this brings us to the equi-marginal principle, which states that in controlling emissions from several polluters, all emitting the same pollutant effectively requires that the marginal cost of emission control be the same for all the polluters. However, there is a difference between the concept of economic efficiency and cost effectiveness. A policy that accomplishes an objective at least cost may be cost effective, but it does not assure that the objective encompassed the virtue of maximum social welfare. However, economic efficiency assures that an objective maximizes the social welfare at the least cost. Hence, all the cost-effective policies may not be efficient, but all economically efficient policies are cost-effective. After studying this module, you shall be able to learn about various policy approaches of environmental regulation. Second, understand forms of traditional command and control instrument. Third, identify various forms of market-based instruments. And fourth, discuss problems associated with each type of regulation. Let us now begin our discussion on traditional command and control or prescriptive regulation. Environmental regulations that are prescriptive in nature are referred to as command and control mechanisms. A policy that specifies a certain amount of permissible level of emission is characterized as prescriptive regulation. Such a policy may also take form of prescribing the type of control equipments or technology that must be used to meet such requirements. The tool usually used in CAC approach is called standard. A standard may be defined as the level of performance that is made mandatory by legislation. These standards are commonly defined in terms of emission rates of polluting firms and hence depend upon number of polluting firms and the output generated by each polluter. Thus, such a command and control regulations do not have direct control over aggregate emissions. The environmental quality standards may be characterized into three categories, namely ambient emission and technology, that we will study in details in this module. Ambient standards. Ambient standards define a maximum limit of certain pollutants in a particular area or region. For air pollution, the environmental regulatory body is required to set ambient air quality standards for some specific air pollutants such as nitrogen dioxide, carbon monoxide, particulate matter, etc. A similar standard for water pollution could be in terms of the levels of dissolved oxygen, biochemical oxygen demand, pH level, etc. If the levels specified under these standards are breached, it leads to a harmful situation for the region. The direct enforcement of ambient standards could be difficult. However, policies may be drafted and legally enforced upon the polluters to restrict their emissions. Emission standards. It defines maximum levels of emissions that a polluting firm or a source may be allowed to emit per unit of time. For example, Bharat Stage Emission Standards are emission standards instituted by the Government of India to regulate emissions of certain pollutants from motor vehicles. Emission standard sets a limit of an emission, and the polluting firms or the sources are required to decide the way to restrict emissions up to the permissible limit. Imposing emission standards might not guarantee that the ambient standards are met. If the emission standards are imposed and there is no check on the number of polluting firms, then the ambient standards may not be met, and hence emission standards may not be able to uphold aggregate environmental quality in terms of ambient standards. Technology standards specify equipments, technological design, input and output practices, etc. that the polluting firm are required to adopt to meet emission standards. Hence, in order to comply with technology standards, the polluting firm undertakes the technological changes or a shift in production process to meet environmental standards. These standards may be useful in cases where the cost of monitoring of emissions are very high, whereas adoption of particular technology or production is easy and less costly. However, such standards discourage firms to do any research and development for pollution control, as they do not have any incentive to invest in more cost-effective innovative abatement strategies or production processes that are not permitted by regulation. Technology-based standards are usually compared to performance-based standards. A performance-based standard specifies source-level emission standards. However, the polluter is free to choose among available production methods to comply with the standard. The level of such flexibility for the polluter depends upon whether the standard specifies emission rate in terms of per unit of output or input or an emission level. A standard expression in emission level permits the firms to choose an appropriate technology or practice to achieve the standards. However, an emission rate is restrictive and depends upon the way in which it is defined. For example, if the emission rate is defined in per unit of output, then a polluting firm might not be able to meet the standards through reduction in output. Performance-based standards are flexible and hence encourage firms to innovate. The firms can choose among the most cost-effective methods to meet the standards. It is generally observed that the performance-based standards provide some incentives to firms to invest in research to develop new and less expensive technology. Now we shall discuss the market-based instruments. Market-oriented approaches motivate producers to incorporate pollution abatement into their production decisions and hence differ from traditional command and control regulations, both in terms of economic efficiency and cost effectiveness. These methods offer incentive to producer to minimize abatement cost to an extent that cannot be achieved under command and control based approaches. Market-based instruments are believed to have more flexibility than traditional command and control regulations, as they rely on the difference in abatement cost across polluters to efficiently reduce pollution. Hence, these methods are considered to be less costly, incentivize producers to adopt better technology, and place lower information burden on the regulator. There could be a number of market-based instruments available to the policymakers, but only 3 of those are discussed in this modules: the tradable pollution permits, emission taxes, and environmental subsidies. Tradable pollution permits are the rights to pollute that are sold or bought in artificially created markets. One generally come across 2 designs of permit system: an emission permit system (EPS) and an ambient permit system (APS). EPS approach often makes use of a set of emission zones within which emissions of a particular pollutant are treated as equivalent, and hence the permits are defined in terms of level of emissions rather in terms of effects of these emissions on ambient air quality. The environmental authority determines an allocation of permits to each zone, and polluters within a zone trade permits on one-to-one basis. The environmental authority issues a fixed number of permits for the region as a whole, and the subsequent bids and offers of participants generate a single market clearing price. From this perspective, EPS is a system in which the entire region is a single market, though it is possible to encounter continually more finely divided systems of zones designed to take into account the spatial character of the airshed. However, regardless of the total number of zones, each pollution source will lie only in the single zone and will consequently operate only one permit market for a given pollutant. There are no trades across zones. Each zone is a self-contained market, and its own price for the permits is determined by the polluter's demand for permits and the supply as determined by the authority. EPS is a simple system which works well in a case of uniformly mixed pollutants. Uniformly mixed pollutants are pollutants emitted by many sources in a region, resulting in relatively uniform concentration levels across regions, like sulfur dioxide or sulfur oxides and carbon dioxide, etc. Non-uniformly mixed pollutants are pollutants that have different effects in different areas depending on where they are emitted, like water pollution from factories, sewage, and runoff from agriculture. For non-uniformly mixed pollutants, however, trade under an EPS could result in violation of ambient air quality standards. For instance, if any source is located in a more sensitive area, then it increases its emission by some amount, will do more damage than a damage avoided by another source by its emission reduction in non-sensitive areas. To get around this problem, the ambient permit system was proposed, where the permits are defined in terms of pollutant concentrations at the receptor points. Permits are denominated in areas of damage at receptors. There is a separate market in receptors. Firms thus operate in number of markets for each pollutant. In the benchmark case, one for each receptor site that has emission effect, and is subject to a different weighing parameter, that is diffusion coefficient, transfer coefficient in each market. The assembling of a requisite portfolio of permits could become quite complicated and may hence enhance transaction costs. There are 2 options that can be considered in order to allocate permits. Auctioning. There are 2 alternative designs for an auction system. The first is the simplest design, a single price option, whereby firms submit sealed bids for permits. Permits are then sold to the highest bidder for a price that could represent either the lowest accepted bill or the highest rejected bill. This mechanism encourages strategic behavior in a way that if a bidder considers its bids to be marginal, then understanding their true willingness to pay might be beneficial. The second alternative is an incentive compatible groups mechanism whereby the highest bidder wins the permit, but the winner's own bid never affects the price it pays. The groups mechanism is influenced by Vickrey's second price auction, where the highest bidder pays the price bid by the second highest bidder. Auctioning imposes an additional financial cost in the firm in terms of the payments they initially make for their permits. Grandfathering. It refers to giving away sellable permits freely to the firm. This process may adversely affect political attractiveness of auctions. Grandfathering has therefore been favored in existing permit schemes, as the revenue generated could be used to resort environmental damage or for subsidizing improvement in pollution treatment capital. Revenues could also be used to allow reductions in non-environmental taxes. Although grandfathering systems have certain benefits, they have been widely criticized in terms of discrimination against new entrants to an industrial area who must pay for permits which existing firms were given for free. Grandfathering creates rents for those firms who receive permits. We could therefore expect resources to be wasted in rent-seeking behavior by potential permit holders. Next is emission tax. It is a price or a fee paid by the polluter to a regulatory entity for every unit of emission a polluter emits. If the emission tax is say P, small p, and the polluter emits X units of pollution, the payment from the polluter to the regulator is P multiplied by X. To determine how much the polluter emits, let's say C X be the production cost associated with emitting X units of pollution, holding goods output fixed. Cost will decline as the pollution increases, thereby implying that the polluter saves money by emitting pollution. So, total cost for the firm can be given as TC, which is equal to Cx plus Px. The total cost is minimized with respect to X, and we obtain small p, which is the emission fee or tax, equal to negative of marginal cost, which is again equal to marginal savings at pollution X. The equation states that the firm operates until a point where the marginal cost of reducing pollution by 1 unit, which is same as marginal savings from emitting 1 more unit of pollution, is equal to the price of pollution. In other words, in the case of emission taxes, the firms will reduce pollution up to a point where a firm's marginal cost of abatement is equal to the emission fee. In the case of multi-firm firms, each firm abates till the point where the marginal cost of abatement is equal to the emission fee. As all the firms equate their MACs, which is the marginal abatement cost, to the same fees, they satisfy the equi-marginal principle and hence maintain efficiency. The equi-marginal principle states that in controlling emissions from several polluters, all emitting the same pollutant, effectively requires the marginal cost of emission control be the same for all polluters. Lastly is environmental subsidies, as we mentioned. These are the payments paid to the individuals or firms by the government. They are generally used to correct externalities or problems associated with natural resources and their use. Market failures lead to externalities. Now, pollution is a negative externality generated during production of goods and services. Arthur Pigou once proposed that if externalities can be internalized and the producers of the externality are made to face the true price, the problem arising out of externality may be solved. A producer generating negative externality, pollution that means, may face tax per unit of emissions. Similarly, producers generating positive externality, for example using green technologies, can be given subsidy to reach the social optimum. For negative externalities, example pollution, the subsidy is levied per unit of abatement of emissions. It can be shown that if the subsidy rate and the tax rate are equal, it will result in same amount of pollution. However, the distribution of the cost and the revenue in each case differs. Taxes generate revenues for the government, whereas the subsidies involve cost. Issues regarding the distribution of costs or revenues concern the policy holders, the policy makers I mean. However, the choice of the instrument does not affect the efficiency and the overall level of pollution. But in certain cases, where the firms can enter or exit the industry in response of such policy actions, the equivalence between taxes and subsidies might not hold. It is worth noting that in short run, when there is no time for new firms to enter the industry, Pigouvian tax, which is emission tax equal to the aggregate marginal damage caused by the emissions when evaluated at the efficient level of pollution, and subsidies might yield the same outcome. Let us consider a competitive industry where all firms in industry are identical. Under a pollution tax, say small t, the production cost of a typical firm would be costs equal to the variable cost plus T, that is pollution tax, into the emissions, that is unit of emissions, plus the fixed cost FC. Now suppose the emissions are related to output such that E is equal to AY, where A is just a constant. Then in this case, the total cost will be equal to the variable cost plus T into AY plus the fixed cost. We may rewrite the above equation as total cost equal to the variable cost plus fixed cost plus T into AY. So the marginal production cost would be, of course equal to marginal variable cost plus TA. Now under subsidy, say E, with no regulation, the firm will produce emissions at the level, say E star. With the subsidy, the firm will be paid to reduce these emissions. So if the firm reduces emissions to E, the subsidy payment will be S within brackets E star minus E. This means that the cost will be, total cost will equal to variable cost plus fixed cost minus S within brackets E star minus E. Now, by putting around certain variables, we arrive at TC is equal to variable cost plus small s into AY plus FC minus S into E star. Now, the term in the bracket is what consists of a standard fixed cost plus a lump sum transfer of S E star, which is independent of Y or E. Consequently, the marginal conditions would say marginal cost is equal to marginal variable cost plus TA. Now, the above equation is same as equation 4 with the difference of T and S. Thus, in the case of identical firm in short run, taxes and subsidies give the same result. In the long run, there will be more firms in the industry with a subsidy than a tax. Subsidy hence might result in the overuse of certain environmental resources which are used as inputs. Also, subsidy might be undesirable because it does not allow the market to communicate the true cost of the product. Combined tax and subsidy schemes may also be a possible economic instrument for pollution control, as both are parts of market transaction. Taxed and subsidized items are easily observed in market and hence they make a good policy instrument. Moving on to the discussion of the choice of policy approach. Now, different policy approaches have different implications and have their set of advantages and disadvantages. Hence, choice to implement any policy depends upon its effectiveness under prevailing circumstances. Effectiveness of any policy in turn is determined by multiple factors discussed below. First, environmental goal. It is important to ensure that policy instrument must be adopted keeping in mind the exact environmental objective. For example, goals of emission reduction and general environmental improvement would require different policy prescriptions. Another important aspect is to evaluate a certain policy in terms of incentives it provides to reduce emissions. The approach should induce firms to reduce emissions by greater amounts than what they would have done in the absence of pollution. Second factor is economic efficiency. The approach must lead to results that are close to the most efficient outcomes. The policy instruments must accomplish environmental objectives in lowest possible cost to firms and consumers. Third, reductions in cost. Different policy regulations involve different transactions, monitoring, administrative and enforcement cost. Hence, the government must weigh these costs before implementing any policy regulation. Environmental awareness. The policy options must not only aim at reduction in emissions but also bring about attitudinal changes among the agents to preserve environment. So along with meeting particular goals, policy must educate firms on nature of environmental problems and alternate ways to mitigate them. Last is the incentive to innovate. Policy instruments should also induce firms to undergo dedicated research developing abatement techniques that would help in reducing the cost of compliance with environmental regulations. Now we will summarize what we have discussed in this module very quickly. There are various policy alternatives to that offer least cost solution to pollution problems. Tradable pollution permits and taxes are both capable of achieving it. Innovation and cost savings over time is one of the things that must be considered, and it's the advantage of economic instrument over design or performance standards concerns. Suppose a firm could install a cleaner technology by adopting a production process with lower marginal abatement cost associated with this. This may incur a cost, but benefits accrue in the terms of abatement cost savings. A tax system relative to a standard is expected to result in a progressive reduction in both abatement cost and emission levels over time. It is argued that emission taxes provide higher incentive for firms to innovate cleaner technologies than emission subsidies or certain forms of tradable permits. The most commonly practiced pollution policy of command and control regulation results in lower incentives for cost reductions in pollution control than market mechanisms. However, tax may do better than tradable permits in this important aspect of environmental policy design. There are three market-based instruments that operate differently. For example, taxes and subsidies are price-based instruments, whereas permits are quantity-based instruments. However, all these three exhibit equivalent functioning in terms of incentives they provide to the producers.